Okay, so we're at the point now where we're going to be multiplying either two binomials or a binomial and a trinomial or something like that, more than just a monomial distributed into the parentheses into all the terms. Okay, now this model here shows you multiplying 2x plus 1 by x plus 2. Okay, so here you have, on this side, you have 2x plus 1, there's 1x, there's 2 x's, there's the 1. And on this side, you have the x plus 2. There's the x and the 1, 2. See that? Okay. Now, what you're going to do is if you multiply each piece with each piece, you're multiplying the 2x times the x, okay? The 1 times the x, and then the 2x times the 2, and the 1 times the 2. Essentially, I'm going to show you a method that's called FOIL that we'll do in a second. But if you do it this way, if you write it out as the tiles, what you can see is x times x, x squared. X times x, x squared. X times 1, x. 1 times x, x. 1 times x, x. 1 times 1, 1. 1 times x, x. 1 times x, x. And 1 times 1, 1. And so what you get is 2 of these x squareds, 5 of these x's, and 2 of these 1's. Okay? Now, essentially, what you did here, and I'm going to show you this is going to be the kind of method that I'm going to teach because you see it a lot and it's pretty handy, is the FOIL method, which essentially says, let's say this is a group of two terms here in the front, right? There's this 2x term and there's this constant term of 1. And over here, there's this x term and there's this constant term of 2. Make that a 2 a little bit better. Okay? So, oops, I'm not sure what's going on there. Oh, okay. What you want to do is we're going to use the FOIL method. The first term in each one, that's the f. Okay? And when we do that first term times that first term, what we're doing is 2x times x, and we get 2x squared. Those are these 2x squareds that you see there. Okay? And then we're going to do the outer terms, the outer meaning the ones on the outside edge of this grouping, right? This outer term right here, these outer terms is this times that, 2x times 2, and you see 2x times 2 is 4x, okay? And then you're going to do the inner terms, meaning these two terms on the inside, that's 1 times x. What do you get when you do 1 times x? You get x, okay? And then these, finally, these last terms with an L, okay? Oh, and I should have done in green, I should have showed you those inner terms right there, okay? And then you're going to do the last terms right here, that last constant term times that last constant term. 1 times 2 is 2, okay? And you'll be able to group some of these together. These right here are both x terms, and you can group them together. And what you get as a result is 2x squared. 4x and x becomes 5x, plus that 2 at the end. And that is what you see them writing right there. Okay? So essentially, the way that you want to think about this is there are two terms in here. This term needs to multiply with each of these of the terms of the second binomial. This needs to multiply with this, and then this needs to multiply with that and with that. Okay? And they'll all have multiplied with each other. We're not multiplying within. This doesn't get multiplied with that because you can see they're separated by plus. Okay? Let's move on and do some problems, and this hopefully will click into place for you. Okay, so they're saying, what is the simpler form of 2x plus 4 times 3x minus 7? As I said earlier, you want each piece of this to multiply with both things in the other binomial. So what they're doing here is they're taking this first one, where you see 2x here, and they're saying, let's take that 2x, and let's distribute that into the binomial. Multiply it by 3x, multiply by negative 7. Okay? And let's take this piece, the positive 4, and distribute that into this binomial. Okay? And when you do that, 2x times 3x is 6x squared. 2x times negative 7 is negative 14x. And they've just done the distributing on the 2x there to get that. Now on this line, they keep this still what it was up on this past line, and this one they're going to distribute 4 times 3x, 12x. 4 times negative 7, negative 28. What can you combine? These two terms can be combined. They are x terms. Negative 14 plus 12 is negative 2, so negative 2x. And these terms don't have anything to combine with them, so they stay the same. Okay? And essentially what you've done is you've taken this and multiplied it with this and this, and you've taken this and multiplied it with this and this. That's the trick. So here's your Gadot problem. Oops. Here's your Gadot problem. Okay, and what you're going to do here is pause the video, come up with this multiplication of these binomials, and combine like terms, write it in descending order, right, or in standard form, and then unpause the video, okay? Pause it right now. All right, so then I'm going to do the method that they did where they took this original x here, and they said, okay, let's take that x and let's put it in front of this second binomial here, 4x plus 3. Okay, and then let's take this second part, this negative 6, and let's put that in front of this second binomial, again, the 4x plus 3. Okay, so 4x plus 3 will get multiplied by x, and it will get multiplied by negative 6. So when you do the distributive property here, we do 4 times 4x, and we get 4x squared. Okay, and we'll just do that times that, right? Then we're going to do that times that, x times 3, 3x. Okay, now we're going to go to the second one. Negative 6 times 4x is negative 24x. And we're going to do this negative 6 times this positive 3, and we get negative 18. Now, which terms can we combine? We can combine the x terms. What's positive 3 plus negative 24? It's negative 21. So we get 4x squared minus 21x minus 18. And that is your answer. You're eventually going to learn how to separate this, but that's for a future lesson. But you'll be able to eventually take this right here and turn it into these two binomials that multiply together to get it. Okay? But we'll do that later. So let's keep going. Okay, so this note here is just saying that when you use the distributive property to multiply binomials, you might notice that you multiply each term of the first binomial by each term of the second binomial. That's what I had just said. And there's a method you can use, a table, that can help you organize this. So we're about to do this on the next slide. Okay, so they're telling you to use a table here, and they say, what is the simpler form of x minus 3 times 4x minus 5? Here's what they've done. They say, well, we know that we've got these binomial factors. Factors are things that you multiply together to get a product. And the product of binomials written in standard form is what we need to get to. So here's the plan, use a table. They've written x minus 3, they put the x term here, the negative 3 term here, and they put the 4x minus 5 up here, 4x here, negative 5 here. Okay? Now, notice this. Is this the only table you could make? No, you could reverse this. You could put the 4x here minus 5 and the x minus 3 here, and you would still get them to interact, okay? In the way that you want them to. Okay, so, and of course, by the way, you want to keep that negative with that 3 and that negative with that 5. So what do we get? X times 4x, 4x squared. X times negative 5, negative 5x. Negative 3 times 4x, negative 12x. And negative 3 times negative 5, positive 15. Okay? Combining these two diagonal-like terms, negative 12x and negative 5x, which you see right there, combines to negative 17x. So you get 4x squared minus this 17x plus 15. Okay? And you can actually, if you write it in a table like this, you could write it like this, or you could just know right away that these combine, and you could write it as the combined form, simplified form, right there, right away. Okay, so you got a problem here. What is the simpler form of this? Use a table. I'm gonna make the tables, and you're gonna pause the video right now, and you're gonna make your own tables and come up with your own simplified answer, and unpause it when you have your answer, and you can compare it to mine. So pause the video now. Okay, so I've made these tables here. Notice that I did this. I made the tables twice just to show you. This 3x plus 1 here, here's the 3x, here's the 1. I put it in a row. Here, I put it in a column, 3x and 1. Okay, and this one, I put the x plus 4, here's x and here's 4. I put that in a column, and I put x and 4 here in a row. I did that just so that you can see that no matter which way you do it, it's going to work out to be the same. 3x times x, 3x squared. X times 1, x. 4 times 3x, 12x. And 4 times 1, 4. Okay? And of course, which can we combine? We can combine these right here because they're both x terms. Okay? And what we would get, it would be the same as what we're going to get over here, which is, watch, 3x times x, 3x squared, just like we got on the left. 3x times 4, 12x. Yep, we got a 12x on that left-hand one. 1 times x, x. Yep, we got an x there. And 1 times 4, 4. We got all the same terms, and they were going to combine the same way. Like I said, this x and this 12x will combine to 13x. So what we then get as a result is 3x squared plus 13x. 12x plus 1x is 13x plus 4. And that, my friends, is the answer to that one. Hopefully that makes sense. Let's keep going. Okay, so these are called area tiles, and what you're seeing right here to do these multiplications, and you're going to see an IXL on the lesson page that you can practice using these algebra tiles or these area tiles. Okay, but let's read what they're telling you here. There's a shortcut you can use to multiply two binomials. Oh, that's nice. Shortcut. Yay. Consider the product of 2x plus 2 and x plus 3. The large rectangle below models this product. This is 2x plus 2 times x plus 3, right? Length times width, so the area is going to be this times that. Okay? You can divide the large rectangle into 4 smaller rectangles. Instead of calling this x and 1 across the top, you can just call that 2x. And you can call that 2. Here, x plus 3, instead of having x and 1 and 1 and 1, you just have x and 3. Okay? And then you can see that you're multiplying this x with this 2x, this x with this 2, this 3 with this 2x, and this 3 with this 2 for all the 4 respective areas. Okay? So what they've done here is, notice what they did. They took this first term times this first term right there. Okay? They took these outer terms, this outer term and this outer term, and they put it there. Okay? And they took this inner term and this inner term, and they multiplied them there. And then they took the last term in each one there, and they multiplied them there. Okay? And you see that everything gets multiplied with everything else when you do that. Okay? That's what I did at the start. Here's what it says. This model illustrates another way to find the product of two binomials. You find the sum of all of the products, like this is a product here of that times that, and you got to get the sum of them, adding them all together. Some of the products of the first terms, outer terms, inner terms, and last terms. The acronym FOIL. They help you remember this. FOIL, first, outer, inner, last. And if you haven't seen that before, now you've seen it, and you're going to need to use it for forever, so learn this well. Let's do a few problems of these. Okay, here we go. We're using FOIL now. What is the simpler form of 5x minus 3 times 2x plus 1? We're going to take the first term right here of each one, 5x, and this first term, 2x. And we're going to multiply them together, and they become 10x squared. That's the first terms. The outer terms, meaning the outside terms, okay? This 5x and this positive 1. Multiply 5x times 1, you get 5x. Now we're going to do the inner terms towards the middle in the inner part between where they are butted up against each other, okay? The inner terms, negative 3 and 2x. Multiply them together, you get negative 6x, okay? And then the last terms, negative 3 times positive 1. The last term in each of the binomials is negative 3. These combine. 5x minus 6x is negative x. And the 10x squared does not get combined with anything. And the negative 3 does not get combined with anything. They are different terms. So the product is 10x squared minus x minus 3. Okay? And here are your 3 got it problems. These should go fast if you know what you're doing. So that's why they gave you 3 of these, because you can do a bunch of them quickly. So you're going to pause the video right now, and you're going to solve these. And when you come back, you can compare your answers to my answers. But the learning is going to happen because you stopped this video right now and you attempted to do these. If you laze out on that step and you just sit passively watching it or fast forward through, don't be surprised if you don't do well. And by the way, there's a difference between scoring well on a test and knowing the stuff. So a lot of people that seem to be scoring well, but they seem to fundamentally misunderstand some of the concepts, and it makes me wonder where they're getting their answers. You want to be somebody who's getting their answers from your clear knowledge of the subject. And any other way of getting an answer down on the paper has no reflection on your ability. Understand? Okay, so pause this video because you want to learn this. Come back when you have these 3 answers with like terms combined. Pause it now. Okay, so first term times first term. 3x times x, 3x squared. Outer terms, this term times this term, 3x times 2, 6x. And since it's a positive 6x, you have to put a plus there to separate the terms, okay? Inner terms, these inner terms here, this negative 4 times x, negative 4x. And the last terms, the negative 4 times the 2 is negative 8, okay? And we can combine these 2 terms here. They combine to be 2x. So you've got then 3x squared plus 2x minus 8 as that final answer, okay? And notice what I did here. This was this term times that one, that term times that one. This top thing was showing how you multiplied this to both things. This bottom thing here is how you multiplied this second term to both things in the second binomial. Okay, let's do it again. First, n times 4n, 4n squared. Outer, n times negative 7, negative 7n. Inner, negative 6 times 4n, negative 24n. And last, negative 6 times negative 7 is a positive 42. Okay, what terms can you combine? You can combine these n terms. Notice that they're the middle terms. That's often, but not always, going to happen. Okay, so you then get 4n squared. This negative 7 and this negative 24 go together to be negative 31n, and then plus 42. And that's the answer for that one. And finally, we've got, no, notice this. We've got here a term that's already squared. Watch what happens when you square it. You say, okay, 2p squared times 2p. Well, the 2 times 2, the coefficients, become a 4. And p squared times p is p cubed. Okay? Outer, we've got 2p squared times negative 5 is negative 5 times 2 is negative 10. And p squared, there's no p's in the second, right here in this term, so you don't get an extra p, it stays as p squared. And now we do inner, 3 times 2p, is 6p, it's plus 6p. And last, negative sorry, 3 times negative 5 is negative 15. Okay? Now, normally here, what we're seeing is you see this x times an x gives you an x squared term. Here you get an x term times a constant, and here you get an x term times a constant. That's why you get these two middle terms that combine. But right here, we don't have that. We have an x squared term times a constant, gives us an x squared term. We have an x squared term times, I'm sorry, I said x, but I meant p. We have a p squared term times a constant is a p squared term. P squared term times a p term is a p cubed term. And then here we've got a constant times a p term is a p term, and a constant times a constant is a constant. They all have different exponents for p, and of course the constant doesn't have a p. So there is no way to combine like terms because all of the terms are different. So I'm going to write it down here on the bottom because it's long. 4p cubed minus 10p squared plus 6p minus 15 is the whole answer, and we're done with that. Okay, and you'll come to understand why it is that this particular one did not have terms that could combine, but these two did. Okay, and it has to do with them having the same thing in here. They both have the same what's it called? The same degree rather of the variable, and here they both are constants. So you're going to get a constant times x to the first power and a constant times x to the first power here. So they result in the same type of term. Okay, but just do it the way that you know how to do it, and it'll work out. Let's keep going. Okay, I just wanted to read through this and also point out that we skipped problem 4. It was needlessly complicated, and we're trying to simplify it down to the core concepts. So we're skipping problem number 4. Okay, here's what this note says. You can use the FOIL method when you multiply two binomials. You have a first and a last. You have an inner and an outer. Okay, but it's not helpful when multiplying a trinomial and a binomial, right? Because then there's more, you're going to result in 6 terms. In this case, 6 I know because 3 times 2. In this case, you can use a vertical method to distribute each term. Let's see what that looks like. I'll tell you there are some methods that I like better than others, but we can do it anyway. So let's take a look at it. Okay, so they're asking what is a simpler form of 3x squared plus x minus 5 times 2x minus 7, and essentially we need to do, it's like FOIL, okay, in the sense that you're going to do this times this and this, you're going to do this times this and this, and you're going to do this times this and this. But you see how it gets all clogged up and messy and not really easy to keep track of? Okay, so we're going to do it this way, or we're going to examine this method of doing it, where you write out the trinomial and you write out the binomial in, vertically, and then you do like regular multiplication. This times this, this times this, this times this, and then eventually this times this, this times this, and this times this. Now, how do you know how to align them? Okay, you're going to write the polynomial so that the terms are vertically aligned, meaning you're going to see always, if you have constants at the end of each one like you do here, -5 and -7, you're going to have a constant term at the end. So this column is a constant term. Then you're going to have an x term. Then you're going to have your x squared terms. Then you're going to have your x cubed terms, and so on. And you're going to leave spaces so that the x terms are stacked, the x squared terms are stacked, the x cubed terms are stacked, the constants are stacked, etc. Okay? So let's do it. Say -7 times -5, positive 35. -7 times x, -7x. -7 times 3x squared, -21x squared. Okay? That's that times that, and that. You've hit all 3 of the things in the trinomial with this. Now we've got to hit all 3 things in the trinomial with this. So this times this. Right away you see that 2x times -5 is -10x. It needs to align with the x terms. You can't put it here. They don't go together. Like terms are above each other. Okay? So 2x times -5 is -10x. That aligns with that -7x from the last one. 2x times x, 2x squared, that aligns with that x squared term, and 2x times 3x squared, 2 times 3 is 6, x squared times x is x cubed, so 6x cubed. That's got nothing to add to it, so it doesn't have anything in that same column, okay? And there's no carrying in this case, okay, because we don't have, you get hit 10 or above and you carry it to the next column. It's just this is here, the sum of these two is here, the sum of these two is here, and this comes straight down. So the product is 6x cubed minus 19x squared minus 17x plus 35. And your Gadot problem in two parts is what is the simpler form of this trinomial times this binomial, and then just like testing your reasoning, how can you use the distributive property to find the product of a trinomial and a binomial, okay? Try it with this method first, and then I'll show you what they mean by using distributive property if you don't know. You can use either method that you know if you know one or the other, okay? So pause the video now, solve this problem from A, and then we'll talk about B as well. So pause the video now and solve this for part A. Okay. So if we were to write it like they wrote it above, where we say 2x squared minus 3x plus 1 times x minus 3, we would get, we're doing negative 3 times each one of these terms. So negative 3 times 1, negative 3. Negative 3 times negative 3x, positive 9x. And negative 3 times 2x squared, negative 6x squared. Okay, now we're multiplying by this x right here. Hope I left myself enough room. X times 1 is x. I got to align it vertically here. X times negative 3x is negative 3x squared. And x times 2x squared is going to be 2x cubed. Okay? And I need to add them all up. And I'm going to write this answer over here to the right. So this part right here, there's nothing to add to that negative 3. So we've got a negative 3. There is this 9x plus that x is 10x. There is this negative 6x squared and this negative 3x squared. That's negative 9x squared. And because that 10x was a positive, we need to put a plus in there to make sure that they stay separated by their signs. Okay? And then finally, this x times 2x squared is 2x cubed, and that's there. So we've got 2x cubed minus 9x squared plus 10x minus 3. Okay? Sorry for that sloppiness. I don't always have plenty of room on these screens. But how can we use the distributive property? Okay, what we're going to do is we're going to take this, we're going to say, for the distributive property, I'm going to resolve this over here on the right-hand side. Okay, and I'm going to say, I'm going to take this x from this first term here, right here, and I'm going to put that in front of the trinomial 2x squared minus 3x plus 1. And then I'm going to take this negative 3 and I'm going to put it in front of the same trinomial that I'm distributing it into, 2x squared minus 3x. Sorry, I'm running out of room here. And that is a plus 1 right there. In case that was unclear, let me erase it and make it clearer. It's plus 1. Okay, plus 1. And when we distribute this through, like this times this, this times this, this times this, we get 2x cubed. X times negative 3x is negative 3x squared. X times 1 is x. And when we distribute this negative 3 through, we got negative 3 times 2x squared is negative 6x squared, gosh, sorry, negative 6x squared. That's that times that. This times this is negative 3 times negative 3x is positive 9x. And this times this negative 3 times positive 1 is negative 3. Okay, now what are the like terms? Well, we've got x squared terms here and here, and we've got x terms here and here. So if we were going to write them in descending order, the x cubed term would come first. We'd have 2x cubed. Underlined in blue are the x squared terms. Negative 3x squared and negative 6x squared is negative 9x squared. The green terms are like terms. X and 9x becomes 10x. And there's only one constant term of negative 3. And if you compare this with this, you'll see that it is identical because you can do it either method and come up with the same answer. Got it? I believe we're done. Let me just end by saying doing a bunch of IXLs and really writing down your work is the way to go on this. You got to trust me that if you're not writing stuff down and you're trying to keep it in your head, you're not going to do well. And if you're being honest with yourself, you can look back at all the times where you tried to meatball something and do it in your head. And if you're being honest, you'll say, yeah, that was not the best way to do it. Did it take me a little bit longer to write stuff down? In one sense. But did it take me less time because I mastered the work so much better and so much more quickly and I was more successful? Yeah. So write it down. That time spent writing it down, you're going to get that time back by having learned this stuff well sooner. Okay? Good luck.